Hi everyone, welcome to Paul Programs, your spot for learning more about game design and game mechanics. Today, we're going to take a look at stacking mechanics. Alright, so before we get started with today's video, if you're interested in learning more about game design and game mechanics, let me know in the comments section below. And if you're interested in seeing more videos like this, don't forget to like, subscribe, and hit that notification bell for when new videos drop. So what are stacking mechanics? I know from a programmer perspective, stacking is usually a pile of objects or something that you basically put on top of each other, or you would push on top of each other and then pop something off the top. But that's not what we're talking about today. We're actually talking about stacks as a game mechanic. And by that I mean basically the act of stacking things on top of each other in a game based on some criteria or other, or basically creating stacks as part of your game mechanic. So to better show this, let's take a look at some examples real quick. Alright, so here we have Bravely Default 2. And the way it handles stacks is basically to, as it says on screen, gather BP, and you can use that BP to basically perform extra actions, attacks, do more damage. So if we actually select Brave, you're actually able to stack each of your different basically attacks or attack power you want. But in the way it works in this game is you're basically spending against future actions if you don't have any BP, which is part of forming the stack. Otherwise, you can actually conserve and not use all your BP and burn through the whole stack by defending, and this is basically a different look at a stacking mechanic and how it's used. So let's take a look at it in action. Alright, let's just spam those attacks, and then you see it goes through the stack of attacks, and then you get to see it right in motion. Another good example would be Uno, where basically you have a stack in the middle, and it's the goal of all players to basically use all the cards and have no cards in their hand. And the way to do that is by matching by either color or by the number that's currently out or the type of card that's currently out. So in this case, we could just throw that 3 on there, and then as you can see, there are exceptions to the rule, but this is basically another good example of how stacking mechanics can be used in a game, as it is the core mechanic of Uno. So these are just two of the examples of a stacking mechanic being used in a game, and hopefully that helps give some insight into what we're going to dive further into. So with that said, let's actually talk about how you would design a game with a stacking mechanic. In our example of a design, say we're trying to make a game where basically the players are trying to be the last player to place a card on the stack no matter what. In that case, we need to take two considerations into mind when we're creating this stack mechanic. One, what allows us to add something to a stack? Basically, what is that criteria that lets us put something on top? The other is, what is the criteria for the stack to be complete? In this case, we mentioned it's basically being the last player to put something on the stack. How do we get there? Well, let's dive a little deeper in by taking a look at some mechanics like Uno. So, when we talk about requirements or rules, Uno basically has the requirement of needing the player to match up what's here in their hand to what's on the stack, be it color or number. There's also exceptions. As we saw before, there's the draw cards, and then there's also different types like reverse or skip, and you can match those with either another reverse or skip or by color as well. So this is just an example of enforcing requirements in terms of deciding what you should actually put on your stack or how you put something on the stack. Thinking about the Uno mechanic, we can then incorporate that basically into our own game as one of the base mechanics, which is matching. Matching is usually the simple mechanic used for most stacking games, matching something with another. So let's go with that. I mean, that's a good place to really start when building out our idea. And then you want to think, what kind of cards you're using or deck. Are you using traditional like poker cards, or are you going to make a specific set of cards for that? In this case, to keep our design simpler, we'll just use a simple poker deck because easy and available anywhere you go. Now that leaves us with a goal, and the goal is to basically be the last player who basically places a card on top of the stack. That means planning when you put cards, when you don't, things like that. And we can always build out other mechanics to deal with edge cases and things like that, but really we just want to focus on the stack and that goal of being that last player to get a card on the top of the deck. Basically to win it all by being first in, last out, last. I don't know. You could come up with your own name for it, but that's basically the goal of this game that we're trying to build. With that said, we've covered stacking mechanics in terms of a design perspective, but let's now take a look at stacking from a coder's perspective. So let's jump into a simple coding example of how you could deal with stacks in your game. Let's take a look at some code line by line and kind of explain how you would build basically your stack structure in code. And in this case, we're using C#. So say we actually have a list to basically represent the internals of the stack we're actually working with. With this, we can add different ints to it, and say we set the rule that every int added to it has to be positive. And there'll be a reason for that in a little bit. Then in a card game, you would think of something like a deck where each card has a value. You may want to pull or check the top card on that stack. That's where something like a pop function works. And what pop does basically is it pulls the thing on the top of your stack off the top so it can be seen, viewed, compared, things like that. And in this case, most important thing we'll do is check to see if we actually have anything in our stack. Get the value of what we're popping off, remove that thing from the top of the stack, and then send that out to whatever's calling this. But in case we don't actually have anything on our stack, then we can do something like send a negative value, and then on the other side, check the value and be like, hey, we didn't find anything in there because there's nothing on your stack. So you might want to set up your stack or do something else. Which leads us to how do we actually get things onto our stack? And it's a bit simpler. That's where we will use like a push and push what we want to onto the stack. And in this case, we'd be pushing an integer onto our integer stack. And it would add it as the last element, and then that would basically become now the top of the stack. And then again, when we want to use it, we can just pop it, and then you kind of continue this motion of popping and pushing. Now, this is just the basics of how you can build your stack structure, but there's other things you can take into consideration. Like you may want something that can quickly tell you how much is on your stack. You may want to be able to just empty everything at once and just do a stack clear. So these are further functions that we can build out over time, but hopefully this will help you get started with getting your stack set up for any kind of stack mechanics you want to plan. Alright, so with that, hopefully you were able to learn a little bit about stacking mechanics and pick up some coding tips along the way. Thanks for watching, and if you want to see more videos like this, like and let me know below, and I will catch you all next time.